In this video, we're going to look at what supporting practices are needed to achieve continuous delivery. If you're not sure what continuous delivery is, then don't panic, we have you covered. Whatever your software system, a monolith, some form of distributed system like service-oriented architecture or microservices, or maybe you've got a combination of everything. Whatever your architecture, there are some common things that apply across the board. Welcome back. If you're new to this channel, then a warm welcome to Narcolepsy Pumpkin. I'm Andy. If you want more content like this, then please smash like and subscribe and click the bell to get notifications. First off, let's address the elephant in the room. What is continuous delivery? And more to the point, what do I mean when I say continuous delivery? So here's the controversial bit. My opinion is that continuous delivery is in effect the first step towards continuous deployment. In fact, you could consider that all continuous deployment processes are in fact continuous delivery processes. It's also important that you achieve a level of continuous delivery before you progress on to continuous deployment. In order to automate the deployment step, you have to first have a step that enables you to produce a reliable, deployable system. Once you've got continuous delivery down and you have a reliable, robust, repeatable deployment process, you're at a point where you can consider automating that deployment. All the steps up until that deployment are exactly the same in continuous delivery as they are in continuous deployment. However, when a software system is something that is physically shipped, that last stage is not attainable. You can't continuously deploy it. So continuous delivery becomes the end game. When your product is internal or a cloud offering such as SaaS or PaaS, then the goal is absolutely continuous deployment. One maybe not so obvious goal is to be working in small increments. And that's not just iterations like sprints, but as close to single piece flow as possible. But you don't have to get there day one. Getting to continuous delivery is a feedback loop in itself. There are many steps along that journey, and it's going to take as long as it's going to take. And it will involve some mistakes, and it's never as simple or as easy as it sounds. So consider it like this. Take a single item of work and get the whole team to focus on that until it's done. And by done, I mean to a state where it could be deployed into a production environment, even if that single item isn't a complete feature or a complete change. Now, to do that, you have to consider the deployment and the release to be two separate events. That's where feature toggles or feature flags come into their own. By masking the change in a way that they can be toggled on or off by the setting in configuration, toggling the feature on or off in any environment or on an environment by environment basis, or even a user by user basis, allows the change to be deployable without any immediate impact on the system behavior. The key parts of that are environment by environment, so it can be enabled in lower environments for testing, and user by user would in fact enable A/B testing in your production environment, should you so wish. There are some advantages to having a more distributed system, as it's easier to only deploy the things that have changed. Anything that increases the potential frequency of delivery and ultimately deployment is a good thing here. This does come with some additional complexity and makes it harder to confirm dependencies that will be affected by a single change. Resolving this, however, is beyond the scope of this video. There has to be a high level of trust and in turn a high level of good practice and discipline within the development team. The focus must be shifted towards quality and at the cost of speed if need be. There's no point delivering poor quality fast, and there is no efficiency in pushing the quality gate down the road to QA teams or dedicated testers. Finding and eradicating defects as close to the source as possible will bear more velocity in the long term and will always deliver value faster. This is where unit testing is a key discipline. I would encourage that good practice be enforced, i.e. that there are valuable tests that cover expected behaviour and all known scenarios. These tests should also prove the absence of all known defects. How these tests are initially written is down to the developer. I would advocate for using test-driven development, but it's not something that should be forced. It should be encouraged, in my opinion, but never forced. It's a bad idea to impose code coverage in these cases. You can find more about that in one of my other videos. I'll put a link to up here and in the description down below. In addition to unit testing, there should be some level of automated integration and systems testing to assert the system as a whole, or the domain as a whole, has not been adversely affected by the changes. This should be with any feature or changes to behavior toggled off initially. This testing can be done by using frameworks and tools such as Selenium, Playwright, Cucumber, or Fitness, to name a few. All of the above need to be maintained. So at some point you make a decision on that feature, whether it's in or out, and any feature flags associated with that should be removed from the code base. The advantages to this approach are that the release of changes to behavior can be controlled independently of the development team's iteration or deployment cycle, taking some of the pressure off QA and user testing happening in lower environments prior to the release, which is now done using feature toggles. This in turn makes the QA team and the release process a mechanism that pulls features through the development team, allowing for more balance of the flow of non-behavioral changes like component updates, security patches, minor bug fixes, architectural changes, and critically the burn down of technical debt. As you can tell, all this changes the dynamic of the software development, shifting the focus to quality and the automated assurance of that quality for each item before the team moves on to the next. In summary, by decoupling the delivery and deployment from the development team's sprint and iteration cycle, we can achieve this by shifting the focus towards quality and then swarming around fewer items at a time. Then by also decoupling the release process from the deployment cycle, we can then shift the final testing and release of features, making it into a pull mechanism, releasing a flow of features when they're ready, allowing for better balance of value types to be worked on. All of that underpins continuous delivery and eventually continuous deployment. If you found this content useful, then smash like. I'd be interested to know what barriers you've encountered trying to put in continuous delivery. If you've got any hot tips or any horror stories, then please add them to the comments below. Don't forget to check out the additional resource links and links to other videos in the description and comments below. Thanks for listening. I'll see you next time.